recording. Yeah. So I'll share the textbook. Let me check. Just 1 second. Okay, we're here. All right. So you see the screen?
Yes.
Okay. All right. It's about like a quiz, chapter 4 and 5. So chapter 4 is a hypothesis testing, and then with the inferential statistic. It's more like a real statistics going on from this chapter, and then you guys are gonna to learn about like how you set up a hypothesis and how you make a test. We don't talk about like the specific testing skill yet, but it's more like a general idea of why we need a testing for those hypothesis testing. So we're gonna learn about like about the hypothesis. The hypothesis is coming from like a research question. So yeah. So research question for simplicity, we could say like you might have like two different types of research question. One is just to ask me like a one parameter. For example, what is the STI prevalence rate among women aged 14 to 19 in the United States? So this one is just asking about like STI prevalence rate. It's not it's not about a comparison at all. It's just point estimation to from the sample. But for like this question, is the oral health of children admitted to PQ significantly different from that of the children in the general population? So this is now is comparing like children admitted to PQ versus children in the general population about the oral health, right? So for this type of a comparison, we need to set up like a hypothesis. So hypothesis, we have two different types. Let me show. Yeah. So one is a null hypothesis. Another one is we call it just alternative hypothesis. Alternative hypothesis can be consist of like non-directional, directional, but don't worry about that yet. But you have to understand about null hypothesis clearly. So null hypothesis is just given information, well-known information has no difference. So we assume that there should be no difference, and we know that. But alternative hypothesis, we want to claim that, oh, there might be the significant difference, right? So if we say, oh, there is the significant difference, there's just non-directional. But if we say, if we want to say, oh, it gets worse or better in one direction, then it should be just directional alternative hypothesis. So based on these two hypotheses, that's the testing whether we accept or reject this null hypothesis or alternate hypothesis. That's all. The statistic testing is about like testing about the hypothesis, whether null hypothesis will be rejected or not, or the same thing for an alternative hypothesis. Okay, it's very, very important for you to set like a right way of like the stating the null hypothesis and the directional, the alternative hypothesis. Okay, so I could give you a quiz question saying, yeah, what would be the right way of like stating the null hypothesis? Then, as usual, we say just no difference will not differ. That kind of statement should be there. But if we say the significant worse or significant better, but that's not the null hypothesis. That should be just alternative hypothesis. Okay. But based on this this hypothesis, what we want to do is we want to test. So, but another concept, very important concept, is whether statistically significant or not. So what we want to say, for example, from your data, right? So you will see the pattern. Oh, I see that the average of this group is much greater than the other group, right? But how can you say statistically whether this group's average is significantly higher than the other group, right? So that's the thing you may want to show using some statistical significance. So statistical significance over here, very important concept, the p-value. So p-value is you had to make sure about the definition of p-value. So p-value is just probability, right? So probability is we could say, oh, just a 0.01 and a 0.05, and it cannot be over than 1, right? The maximum value of probability is just 1, and minimum is just 0. 0 is not happening, 1 is always happening, right? And we could tell the p-value is just probability, but what's the probability? It's over here. So p-value of any statistical test represent the probability that the result will obtain by chance alone. So this is a very abstract and ambiguous way of describing. But for the detail, the p-value is show that it just whether you using your sample, right? Using your sample, it's a probability of just accepting like your null hypothesis, right? So if the chances, the probability is getting lower and lower, that means it's not likely to accept like, your null hypothesis. So in other words, it's a higher chance of rejecting the null hypothesis. So rejecting null hypothesis means we want to just accept the alternative hypothesis. This is a very it can be very confusing. But if you read through this textbook, I will help you to understand about like what's it rejecting, what is accepting, and how we calculate the p-value. I'm not asking you to calculate the p-value, but I hope you to understand about the concept of p-value. Okay, so that should be on the quiz. Represent the precise chance of getting the result and derived from the value of the computed test statistic. So p-value is computed statistic value. So computed the probability value, right, from your sample. So if you draw another sample, the p-value might be different than your sample. So that's the thing. When you collect your data, you should be very careful to draw the conclusion. You may want to draw the conclusion, say, oh, in general, based on my research, I think based on this p-value, the null hypothesis should be rejected. Which means I see the significant difference between certain two groups or some other ways. But that result is from your sample, okay? So don't confuse it with the like a generalization of the all other population, all right? So it's from your sample. It'll be very difficult to say, oh, in general, this sample should be representing the all population. We don't know yet, right? So we have to get through the whole like randomization process to represent your sample is to represent the population from your sample. Okay, so this is a very very delicate and sensitive issue of like randomized clinical trial. When when we develop a new drug or something, then we want to generalize to the population, but we cannot do it. That's impossible to test all the population using the new drug. Okay, so that's why we want to just sample randomly chosen sample and then test them whether this medicine is effective or not. All right. But the thing is that the sampling itself it's very questionable. Are you really randomly sampled for this the testing? Uh, that's why the clinical for like a regular clinical trial, FDA make a lot of protocol, very strict protocol. You know, these days, a COVID-19 vaccine or any just a treatment, we want to delve into that. But it's very difficult to make it just randomized. Okay, and so also it's very hard to collect the samples. I think that they're very struggling with the samples now, even though they're all over the world, a lot of patients out there, but we had to find a way. Oh, it's not only for a certain group, right? It should be just adapt to the all different types of groups. So that's why the clinical trial or randomized clinical trial that should be that's a very difficult part to get a like a real get obtain the real randomness. But anyway, it's a side story of that. So what we need is a statistical significance. To represent the statistical significance, the p-value will be required. The p-value is a computed the probability, and I just want you to make sure about the definition of p-value. Okay, and the p-value also we said that like a significant or not based on certain level of significance level. So significant level is just nominal, predetermined level. So beyond the significant level, we say, oh, that's a now significant or not. Okay, so usually that we call it just alpha level. Alpha level is a predetermined value. It's before conducting any testing, we have to set, oh, if my calculated p-value is less than that certain alpha level, then we define that as a statistical testing is significant, right? So to say significant or not, we need a certain criteria. P-value is calculating the probability, but whether we reach up to certain criteria or not, that criteria we call it just alpha level. Okay, so usually alpha level we say like a 0.1, 0.05, 0.01, but you will see that we'll usually use a 0.05 as a significant level. Okay, so uh, alpha level 0.1 means, so for example, it cannot occur more than 10% of the time by chance. So that's the standard marginal, like a bottom line to say our testing results are significant or not. Okay, so for example, well, you may heard about like, oh, p-value is less than 0.05, then we can tell that statistical testing is significant. But 0.05 is by predetermined alpha level, right? So 0.05 is alpha level. So I hope you do make sure about the meaning of the alpha level. So that's the talk about like a alpha level is talking about like a statistical significant or not, and type of errors also. So make sure about like a type of error, um, type 2 error. So make sure about this table, right? So if you see that this table, when the null hypothesis is true or false, and your decision is accepting the null hypothesis or reject the null hypothesis. Okay, so if the null hypothesis, if null hypothesis is really true, that's a true, but your testing result also accept the null hypothesis. That's what we want, right? Oh, that's reflecting the truth from the sample. But the problem is coming from like whether when your null hypothesis is true, but your testing result is reject the null hypothesis. So it's sort of like a false positive, right? So for example, I give you the one example is this. Um, sometimes we say there's no difference. That should be just true for certain the testing or something. So no difference is true. But we see that's a significant difference from our sample, right? That's the false positive. So false positive rate, we say that that's the type of error. And the other way, it's like when null hypothesis is false, but it's failed to reject, but that means that this accept the null hypothesis. That means that there's also error, right? So then we call it just a type 2 error. Okay, so I hope you to clearly understand about like a type 1 error, type 2 error, because type 1 error itself is related to the alpha level. The type 1 error itself is just alpha level, right? So probability over here, probability making type 1 error can be decreased by the setting of the more stringent significant level. So in other words, you could set alpha level 0.01 instead of 0.05. So alpha level over here is related to the type 1 error. Okay, so hope you to understand this chapter and the paragraphs over here, and the type 2 error also. Uh, yeah, and the power is just 1 minus type 2 error rate. It's just, we call it just 1 minus beta. So beta itself is just type 2 error rate, but when we say like a power of the study, say just 1 minus beta, that's it. So for your level, it's just better to understand this way. Oh, just 1 minus beta is 1 minus type 2 error. That should be the power, right? So conceptually, the power means this one. Power means is its ability to detect the statistically significant difference. Yeah, that's what we want. When the power is higher and higher, that means its ability to detect a certain significant difference is getting better and better. Okay, we want to have that the higher power. If we don't have like enough power, that means you may have some problem with testing. So we want to have like enough power to make like a statistical testing. Okay, so just hope you to understand about the concept of the power also. So for example, um, when we conduct a study, you know, I told you it is related to type 2 error. So if the type 2 error rate is and high, right? That means we're gonna have low and lower power because they will likely to make a dead error, right? A type 2 error. So what we want to do is we don't want to have like those type of errors are high. We want to reduce the type 2 error. Then in the same way, the power will go up. So I hope you to just check. Oh, when the type 2 error rates is getting higher and higher, then the power is getting lower and lower. Okay, so those things I hope you to check, and they should be on the quiz as well. Okay, so the definition of a type 2 error also I told you about, like when a null hypothesis is not rejected, which means accept the null hypothesis, then the real like the diagnosis is just false. Then that's the type 2 error, right? So please understand about this table. And next one. Yeah, this one is all history about like how we calculate that those are power issue. But yeah, don't make yourself just fall into the details of this understanding of this part. But I just want you to get the concept of what is power. and what is type 1 error, and what is a type 2 errors. Those things, must be enough. Okay, yeah, and a lot of things is mentioning over here. Just put it is for your information. Yeah, I'm not gonna giving you any detail uh, like questions beyond beyond the things I mentioned previously. Okay, and especially for sample size issue, it will be just beyond this course level. So I don't think you guys need that that much, right? But for here, this is a sort of the important too. Yeah, don't worry about this table, but I hope you to understand this one. It's a 6 steps testing hypothesis. This is what we usually do. So testing itself is a sort of different ways. So we could use it like a t-test or chi-square test or just ANOVA test and some other very different ways. But in common ways, first of all, we have to state the hypothesis. Okay, so both null and alternative. So you have to set that. So the hypothesis is coming from what? Your research question. Okay, so I told you your research question should be testable and quantifiable. Then we can make this hypothesis, right? And the second step is to define the significant level. Usually, its alpha level is a 0.05. Okay, so choose the appropriate test statistic and determine the critical region and state the rejection region rule. So based on this significant level, what we can do is we're going to calculate test statistic from our sample and compare this test statistic with the critical value based on this significant level, right? So then we're going to have like a different region for our distribution. So certain region is like a non-rejection region, and the certain region is a rejection region, right? So fall into the rejection region means that means that we're going to reject our null hypothesis. But if we fall into like a non-rejection region, it's just okay, just accept the null hypothesis. So I'm gonna show you how we set up this one later, but we have to define the significant level at the second step and then make sure that all assumptions necessary to compute the test statistic. It depends on the different types of testing method, right? And the computer parameter that being compared the test statistic. For example, when we want to compare like an average, then we have to show the average, right? But the average itself is not enough to show everything. We have to show the variance or standard deviation as well, right? And based on that, then we're going to compute the test statistic and compare to critical value and calculate the p-value of it as a fifth step, okay? And then we can determine whether this result is statistically significant or not, and then we can draw the conclusion. Because this is just a typical way of make testing and statistically, okay? Yeah, I just get through the whole thing. So, but I